Hello and welcome back to the video on our final exam, fall final exam. So first of all, I would like to talk about this equation. It's called equation in vertex form. So the reason why it's called equation in vertex form is because you can immediately find the information what is the vertex. So vertex is going to be HK. So you need to look at the parentheses and you have to take the number for h, you just have to change the sign. So because of this minus h, our h will always have the opposite sign. K, there's no sign change. So let's say that our first question was asking us what is h and what is k in this problem. Let's look at our graph. We see that the vertex is 1, 3. So we see that 1 is our x-coordinate, in this case h, so this is, if you think of it xy, you also can think about it hk, right? So that we can use this for the equation. So our h is our x-coordinate, which is 1. Our k is our y-coordinate, which is 3. So now we have that information. So this will be 1 and this will be 3. Now, next question is asking us what is A. So to find A, we're going to use the second piece of information, and this is this y-intercept 0, 6, which means when x is 0, y is 6. So I'm going to use that information and substitute it in this equation. So I'm going to substitute first y is 6. So 6 equals 8 times my x is 0, so I'm going to put 0 for x, minus my h is 1, remember h is 1, squared, plus our k is 3. So let's now simplify this. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So I have 1a, or just a, plus 3 equals 6. To solve for a, I need to subtract 3 from both sides, and I have that a is 3. So now, if I was asked to write the equation using the 3 pieces of information that we discovered or that we found, our final equation would be y equals a is 3, so 3, x minus h minus 1 squared, and then plus 3. That would be our final equation. You can also enter this in your calculator if you wanted to verify that you get this graph. All right, let's look at another type of a problem. A cuboid has the following dimension: length, width, and height. What is a cuboid? It's simply a rectangular box, so we know how to find the volume of this box. The volume of the box is going to be the length times the width times the height. In other words, in this case, 9.6, so V equals 9.6 times 7.4 times 5.2. So that is going to be our exact value of the volume that they're asking us, and if you enter this in the calculator, you will get 369.408 centimeters cubed. Now, to round this to 2 decimal places, remember how to do that. Just looking for 2 decimal places, and our third decimal is 8, which means we need to round up the previous decimal. So our answer for part 1 will be 369.41 centimeters cubed. The answer for part 2, 3 significant figures, that's 369. The next figure is 4, so we're just going to round it down to 369. So 369 centimeters cubed. Next question, write your answer from part B2 in the form 8 times 10 to the k. Okay, what they're asking us to do is write this in scientific form. So the answer will be 3.69 times 10 raised to the second power centimeters cubed. So we had to move this decimal point 2 places, and that's why it's 10 to the second power. Okay, let's look at another problem. How do you differentiate problems that are asking you about loan payments and savings? For example, you take a car loan for $10,000, 4.4% amortized over 5 years. What are your monthly payments? What they're telling us N is the number of periods or number of payments that or monthly installments that you're going to pay over 5 years. So you can enter 5 times, because you're paying monthly, that's going to be 5 times 12 or 60. Interest percentage, that's 4.4. Present value is the amount you took from the bank, $10,000. Future value will be 0 because you plan to pay it off. Payments per year, compounds per year are 12 and 12. And so we have over here, we're going to look for the payment. So that's one thing we do not know. So we want to use our calculator for this. We want to go to Apps, Finance App, and then TVM Solver. Number of payments, 5 times 12 is 60. 4.4 is the interest rate. We took out $10,000 as a loan. It's going to be positive. We don't know what the payments are going to be, but the future value will be 0. Payments per year and compounds per year, 12. And so let's go back to the payment and let's do alpha, enter. We will get what our payment is going to be, $185.98. So $185.98. That's our monthly payment. How much did you pay in interest? Well, we paid every month $185.98. When I multiply that times 60, why is it times 60? Because it's 5 years and times 12 months per year. Let's see how much did we pay in total. So if I exit this solver, I have $195.96 times 5 times 12, that's $11,157.60. So that's $11,157.60. Now, we want to find out how much did we pay in interest. The loan was only $10,000, but we paid $11,157. So we want to see how much extra did we pay for interest. So this will be, you just subtract 11,157.60 minus 10,000, and you get $1,057.60 paid in interest. Now that's one type of a problem. Another type of problem has to do with savings. So now, let's say that we invested $10,000. Here's the interest rate. It's compounded monthly. How much will you have in your account after 5 years? So I know that number of compounds in total, or payments in total, how many times does the amount compound, is going to be 5 times 12 again. So that is 60. Interest rate is 3.3%. Then the present value is $10,000, and I'm putting minus because you're giving the money to the bank, the cash flow, so it's going from you to the bank. Future value, we do not know what it is. We'll find out. Payments per year, compounds per year is going to be the same, 12. So 12 and 12. But you do not enter anything for payment. So let's go back to our financial calculator. Apps, Finance, TVM Solver. So still 60. The interest rate is 3.3. Now we're going to put negative 10,000. Next payment, we're going to put just 0. Future value, we do not know payments per year and compounds per year are okay. All I need to do is press alpha, enter for a future value. So the future value is going to be $11,791.26. So let's see, $11,791.26. So this is the future value. I just wrote it here. Future value after 5 years, compounded monthly at this interest rate. So that's the difference between the loan problems and the savings problems. Let's look at this problem. So we have a bacteria colony A. So the model represents the growth of the bacteria. So let's find out what's the initial count of bacteria. The initial count means that T is 0. A of 0 equals 20 times 2 times 3 raised to the 0.1 times 0. This whole part, because it's raised to the 0 power, is going to be 1. So this is 1 times 20. This is just 20. So there were 20 bacteria to start off with. Okay, let's see how many bacteria were there after 3 hours. So we're going to do 20 times 2.3, raise that to 0.1 times 3. Okay, let's see what that comes out to be. So 20, I can just use the calculator, second quit, 20 times 2.3, and raise that to, I had 0.1 times 3, that's just 0.3. So raise that to 0.3 power. We have 25 bacteria, so we have 25.67, so we're going to round up to 26. How many bacteria? When did the bacteria reach the count of 600? So they're giving us that A of n is 600, but we do not know what the n is or what the time is. I'm sorry, the t. T is what we're looking for. So t. So we have over here 600 equals 20, 2.3 raised to 0.1 t. So to solve this, divide both sides by 20. We're going to have over here 30 equals 2.3 raised to the 0.1 t power. Now, to solve this, we're going to use log. Base is 2.3, argument is 30, equals 0.1 t. So let's use our calculator to calculate this. So log of 30 divided by log of 2.3. We have, this is 4.08. Okay, so, and there's a lot of decimals. Now I'm going to show you what to do because you're trying to get as accurate as possible answer. So you're going to divide both sides by 0.1 because we're trying to solve for t. So use what you have in your calculator and now divide that by 0.1. And we have the information here that this is t is 40.8. So this was t is in minutes. T is in minutes. All right, so they will be 40 minutes, 40.8. I'm sorry. So yeah, it says hours, but it should have been minutes. So hours. So now we have the second problem. The second part, different bacteria colony, where it's starting with a different initial value. and has the same base, 2.3, but we do not know what K is. They're telling us at 3 hours there are 90 bacteria. Okay, so let's see what K is going to be. So we have that B of 3 equals 90. So let's use that information, and we're going to substitute 90. So it should be B of n. 90 equals 32.3. So it's going to be K times 3, so 3K. The reason why is we're plugging in 3 for T, so T is 3. So now let's solve this. Divide both sides by 30. We have over here 3 equals 2.3 raised to the 3K, which means that 3K equals log of base 2.3, argument is 3. Let's put that in the calculator. Log of 3 divided by log of 2.3 equals 1.31. Okay, 1.32 almost. So we have that over here, 1.32 equals 3K. Now we want to divide by 3 both sides, so use what you have in the calculator and divide it by 3. This is 0.439, so I can round it to just 0.4. So 0.4 in this case. So now the equation would be B of n equals 30, 2.3, 0.4 raised to the exponent is 0.4 raised to times t.